talk about version control and best practices that I've learned the hard way. Uh, First, let's just talk a little bit about me. So I'm Petri Liuska and started making games when I was 8 years old. And in the prehistorics, I studied business IT in Haapajärvi and also went through GAMC, as in Kajaani University of Applied Sciences, specialized in game engine programming, and then been involved in quite a few local companies, most recently Black Smoke Studios, and my role is tech lead slash lead programmer. And there's the first game console that I had and also my first computer. But yeah, let's just get down to the topic. So just so that everybody knows, I know that certain things here are probably already very familiar to you, but version control is just managing the project state revision by revision and making changes to files and committing new versions, creating new revisions, and yeah, nothing more complicated than that. And there are mainly two different kind of version control systems. They are centralized ones and distributed ones. Distributed ones, they have many sources of truth. For example, Git is a distributed one. So each contributor has the full history and their commits modify the local copy and they need to push and pull to synchronize with the server. Well, if they even have one, that's not required. And centralized version control systems, they have one source of truth. So they have the full history is on one central server. And when you commit, they go directly to the central server. Let's get to the individual systems. Like Git seems to be something that most of you seem to be using. That is a distributed system, as I said. And then there's Unity version control that I found quite a good alternative to Git. And it handles binary files a bit better than Git. At least it's easier and less configuration. And with Unity version control, you can have this nice clean view for branching. And I found that, for example, artists and less technical people have found it more approachable than Git. And Plastic can be both centralized or distributed. You can make it distributed by having a local server of your own that you then sync with the central server. And then there's good old SVN that also handles binary files a bit better than Git, but I found that the branching and merging with SVN is a bit more clumsy. And SVN is also centralized. And then something that you didn't probably expect, Google Drive. All the Google documents, they do have history available. So I count them as version controlled, and it can be very handy. At least I've used that feature quite a lot. I've returned some documents to the old version or just dig through the older versions of a document and recovered some parts. Can be quite handy if you haven't done that before. But don't use Google Drive for source code. In the prehistoric, some people used Dropbox for source code and it was awful. But I don't quite know if Dropbox is even a thing anymore. And yeah, Google Drive is centralized. And a few words about different clients, because you might think that you hate the version control system that you use right now, but you might just hate the specific client. You should try different ones if you find it difficult to interact with it. For example, command line interface might suit certain people, but graphical clients can be quite a lot more user friendly. And even they have a lot of variation to them. For example, my preference is using Tortoise, Git, and command line together. And I don't like GitHub Desktop at all. Used it for certain projects, but then I just couldn't get myself to like it at all. It just seemed that it was hiding too much and trying to make it a bit too streamlined. But yeah, let's now get down to the actual practical things. This is probably the most minimal setup that you can have, just the main branch, a few revisions, and some projects have gone through their whole, like the whole life of the project has just been like this, that nothing more complicated than this, and that can be fine for certain projects. And the revisions have IDs. SV and Unity version control, they use just numbers, number IDs, and Git uses these hashes. But those aren't very good for human beings, so we have commit messages, and yeah, but this is something that I recommend, that you should ban commits without messages. And you can do that with most version control systems, because if you allow commits without messages, you end up seeing them in the end, and that's not very good communication. But even if the messages are required, they can end up being just nonsense. As you can see there, stuff, lol, something, or just tweaked some stuff, some changes, a lot of changes, that kind of things, not helping anyone. These look a bit better. Add tree prefab, fix rain particle effect sorting issue. These kind of things are a bit more helpful. So how do you write good commit messages? Well, try and state what and if it's relevant, also why. But sometimes the why would be because the producer told me so, so then maybe don't include that. And use the imperative mood, as in make them sound like comments, so the messages are consistent and quick to read. For example, add button for login in the main menu. Clear. Simplify player spawning logic to improve maintainability. Also clear. And through commit messages, you communicate and collaborate with your team more than you would even initially think that you would. You also communicate with yourself. It's not uncommon to go through old commits or old branches and history of different files in version control. So you end up helping yourself if there are some comments explaining that what is going on. And sometimes might even make sense to write in paragraphs. You could have this subject there, like make the police NPC run faster, and then just an empty line and then a longer description. This change was necessary because it was too easy for the player to escape. However, now they might catch the criminal NPCs too easily. I didn't have time to test. So now, when someone goes and tries to figure out the problem, that why they catch the criminal NPCs too easily, they know that why this kind of change was done. But this kind of long descriptions I found, at least in the projects where I've been that they are fairly rare, but when you use them right, it can save a lot of time. So when it's something cryptic, you should use something like this to just explain that here's the thing. But let's get back down to our minimal setup. So how do I know that which commits are stable enough to make a build? Yeah, you could write commit messages that could state something about that, but that's not that practical sounding. And how can we allow other people to work on unstable things whilst we try to stabilize for the build? Yeah, we could tell that, yeah, just don't commit anything now, just work locally. Now we are trying to stabilize the build. No one commit anything, but that's not very practical. So we could add this dev branch that I think some of the teams do have. And with the dev branch, people can work on the things, can work on the unstable things, whilst the main remains just stable. And we can even dedicate the main branch for releases. And we can take this even further and we could add a staging branch. And then you can make this kind of release candidate builds that you can then test them before delivering them to the end users. And as an alternative to the previous one, you can also fix stuff directly in the staging branch, but then you need to remember to merge it back to dev instead of fixing it in dev like in this picture. But yeah, this should already, if you are stuck with just having main and have seen the friction that it causes, this can already help you quite a bit. But this is not even my favorite thing yet. Alternative to those staging branches that are more like a permanent branch, you can have just dev and then release branches that you use. Or you can even combine those models. Nothing stops you from having release branches with a staging branch. If that works for you, if that's the optimal workflow for you, why not? And with this kind of release branch model, of course, after you've merged to main, you also need to remember to merge back to dev. And sometimes you might have a problem in your main branch, but you've already moved on in your other branches. Then you can just make a hotfix branch where you fix the problem and then merge back to main, make a new release, remember to tag it, and then you can merge to dev. But this is the big thing. This is my favorite thing about improving your workflows with version control, adding task branches. And I mean task branches, not feature branches, because I find feature a bit too big of a unit. Tasks should be small and the task branches should be short-lived. We talk maybe more about hours to days than weeks to months, and this allows you and other people to work on multiple things at the same time without causing any problems to anybody else. And you can even name the task branches with the IDs that you have in version control. And then you have your tasks, sorry, not version control, project management. So you can have it synchronized with your Jira or whatever you use for project management. You can see on your version control that what tickets are being worked on right now and what have been merged and so on. And you can even automate it so that they are connected, but let's not go to that yet. And to fix the problem with humans that we aren't that good with just numbers, you can also add this short text description to the task name. For example, UI fix, boss battle, whatever the task is in human terms. So both your project management and the humans in your project, they understand what's going on. And those task branches, they can be combined with this other one of my favorite things, code reviews. So before you merge your task branch back to dev, you should ask someone to check it. And when you use Git, these are called pull requests. The review goes through your changes with some thought, hopefully, thinking things like, is there something difficult to understand? And flagging those things. You shouldn't be shy, you are not stupid. Some things can just be difficult to understand. If there's any friction in reading the code, that it's going to slow you down, so don't take pride in understanding very complicated things. Just try and make them simpler, if you can. Or is there something that could be easily improved in the code? You can just add comments to those things. Or is there a typo that could be fixed? Or is there a bug that you discovered or an edge case somewhere? And then the author of the branch can then fix those things that you pointed out. And then you can later give the branch green light and that's it. But even sometimes you can even find things that are fairly difficult to fix on the spot. But then you can just flag them on version control and get back to them later. So you don't hold the branch hostage. You just flag a new issue and fix the problem that you found later, because sometimes the problems you find with code reviews, they can be completely unrelated to the work that you did with the task. And yeah, code reviews, they do take time from your already busy team. And yeah, that is cause of friction. But also I found reduce the amount of bugs. Especially this kind of little stupid mistakes that all of us do that could have just been avoided if someone else would have just even glanced at it. Or you could have noticed if you would have glanced at it the next day. And code reviews also improve the quality of your code. It's not just about bugs, but it becomes more readable. It becomes easier to understand when other people than just you have to understand it. And it makes your team more familiar with the code base. Jonas, I think you are not muted. Yeah. But yeah, it makes your whole team more familiar with the code base, so even the most obscure systems that maybe one person in your project has only worked on, those become at least a bit more familiar to other programmers in your project. So if that person happens to be ill and there's a build to deliver, someone else, it's easier for someone else to jump in and start fixing stuff. And it makes people talk. This make people talk, and it lowers the threshold for reaching out for help because they are already used to asking for feedback for their code through reviews. So there's not such a high threshold to ask for help or ask for advice or ask for thoughts. And it creates this culture of openness and humility and this healthy, friendly criticism. I'd say that they improve the atmosphere of the team. So I found them worth it, and I think they save time, both directly but maybe even more so indirectly. Yeah. But of course, there are also going to be conflicts. Someone else made changes to the same file, and now you need to try and sort it out. And this, there are a lot of simple conflicts to solve. Then there are some tremendously difficult conflicts to solve. I think the worst case of this, it wasn't just one conflict, but this was a nightmare of a client project where I tried to merge this one branch for 2 weeks and then just had to give up, and we had to just redo one half of the work. So preventing conflicts, it's easier than dealing with them. So how do we prevent conflicts? If you can use text serialization with any software, do it if you are using version control, because binary files, they can't usually be merged. And split your project into small files. This is not any kind of strict limit, but aim for maximum 200 lines of code per file. And split large classes into smaller classes. That can be done usually. If you're using Unity, not everything has to be mono behavior, for example. You can, for example, have mono behavior that just has a lot of normal classes that it utilizes for the functionality it offers. And if you can't split the class, then you can split the functionality with partial classes, and that also makes things cleaner, but prefer to split the classes instead. And you should avoid nested classes. You can move them outside the class where they are nested in, because sometimes creating nested classes is just laziness. But when it isn't just laziness, when it's a proper encapsulation strategy, then you can use partial classes to have them in a different file. So try and make your code files as small as possible. Same applies to scenes. You can use prefabs, subscenes in Godot, and you can split your scenes into multiple scenes sometimes, and that helps. But those are still subscenes in Godot. But yeah, just many as small files as you can. So a lot less conflicts when someone's just working on one little thing. And make frequent commits. Don't go without committing for a week or even for a few days usually. Make frequent commits with a little amount of changes. Try and make that a habit. It can be difficult at first, but try and get used to it. It helps you yourself as well. And write those clear commit messages of your intention. So if there is a conflict, someone else has to sort it, they know what were you actually trying to do. And your features, as I talked about tasks before, split them into small tasks. and work on the tasks in your separate branches. And small tasks, they make short-lived branches. As I said, prefer hours to days over weeks to months. And yeah, you might notice a trend here. Just make things small, short-lived, frequent. Just holding on to the work for a long time or building something big and then at once throwing it in, that's asking for trouble. Someone working their own branch for 2 months and then trying to merge with everybody else's stuff, that's not gonna fly. And even if you have to do that, there's one way of working around that. You can merge from everybody else's stuff, like from dev to that branch frequently until the feature that you're working on there is done. So even that can be worked around, but just don't go without any kind of synchronization for a long time, because that just makes it messy. The horror merge that I talked about earlier, that was that kind of scenario that without other people knowing, someone had done exactly that, worked for months in a separate branch, and then suddenly we found out that we need that stuff and didn't go well. Still a bit more about preventing commits. So if there are these difficult to merge assets, you can coordinate changes to them with your teammates just by communication that, hey, I'm going to reorganize the scene of Doom, don't touch it. Some teams use rubber ducks that if the blue rubber duck is on your workstation, then you are allowed to work on this specific scene. Or you can just use locks, because a lot of version control systems, they support locks. You can lock certain files so other people can't edit them until you release the lock. You've locked the file, it's yours. And if there are these difficult merges, because even if you do all of these things, keeping it small, something slips and you might need to do a difficult merge. Then you can create an integration branch for that merge. So you branch out from your target branch and merge the source branch to your integration branch. So you branch out from dev and then merge the task to your integration branch. Then in your integration branch, you can fix any conflicts. You can even make multiple commits there and test that it works well. You can even make builds and try that. Does it now definitely work? Did I definitely not break anything? And then you can just merge it to the target branch, back to dev, and that's sorted in a clean way without having to merge it first to dev and then spend multiple commits there in the dev branch trying to fix it. And there are a lot of ways to also improve your productivity with version control, because sometimes you have to jump from one task to another, and sometimes you need to see how something works or looks in a different branch, and you have some work in progress. So what do you do? Well, you might know this, but you can use these shelves in some version control system stashes to temporarily just store your local changes whilst you try something else. So you don't need to make this crappy rushed commit and write a crappy message there. You can just shelve the stuff that you were working on and switch to that different branch and check how things are. But I found an even better method this, because Nothing stops you from having multiple checkouts of the same repository. I often have 3 checkouts, so they all can be pointed to different branches. I can look at different things there, make different changes, work on different tasks here and there. And I can have 3 instances of the game engine open at the same time and just check different stuff. And I found that that's just reduced a lot of my downtime. Ignore lists are also something that's quite important. You should use by default the default templates that you can find online for your engine and third-party components. You might still have to make some custom changes. You might have ignored something that you shouldn't have, or sometimes you need to include files that you shouldn't usually have to. For example, in one version of Unity, there were some settings in this one file that was in the library folder. So had to include that, even though you shouldn't ever include the library folder. And at times there are just new files that come up that need ignoring. Some projects can be challenging to ignore efficiently. For example, WIs, that's the proprietary audio system. It can be difficult to create the good ignore rules for that kind of projects. There are some general rules that if the file is always automatically generated, you might want to ignore it. Or if it's personal to each user, like software user settings, you might want to ignore it. Not everybody, for example, wants to use the dark theme, so people can have that choice without it being in the version control. But sometimes it can be genuinely very difficult to decide whether something should be in version control or not. For example, if there's one file that has certain settings in it that are user settings, but also has got settings in it that should be shared, what do you do then? Difficult. Binary files I already mentioned before. SVN and Unity version control handle them without any configuration. Git needs this large file system that can be a pain to configure, and it can cost extra money if you have big files. So even that you should use some kind of default templates that you can find for your use case, but you might have to actually customize the rules at some point. You should check occasionally whether there are huge blobs there, the repository that should be in the large file system. But it might not even be worth it for a simple and little game that just has small assets. And if that changes, you can always migrate your repository to use the large file system. But there are some limits to that. If the repository gets very huge, I have a practical recent example that I've been struggling with. There's this repository that is over 1 terabyte in size that would need that sorting out, and that's just going to take a lot of disk space to do that migration, and with these prices it's tempting to just use a virtual machine on the cloud for that. But yeah, then there are different operating systems that people might use. I've seen this in a lot of teams, and I think it's becoming more and more common. So some differences can make it a bit difficult. Windows is not case sensitive, but Mac OS and Linux are, and I'm talking about file names. So if you have files hello and hello, but one of them is in capital. Windows sees one file, and macOS and Linux, they correctly see two files. But have fun sorting that out when they are both in your version control. That can, and that has broken a few things in certain projects, and it's been quite precise surgery trying to fix that kind of problems. So you should be aware of it. And if your very long file path Windows is just, yeah, you can change the setting for Windows to allow long file paths, but I don't know if that's still this day, if that's the default setting. Linux and Mac OS, they don't care if you have long paths, but those can kill Windows. Mac OS, it generates these rubbish files that I've seen in a lot of repositories, those DS store files. You might have seen them. And all of those operating systems use slightly different line endings, but if they become a problem, you can just stop Git from automatically converting them to different users, because by default Git uses the Linux way and can convert it to the other operating systems, but I found that that's not a good default a lot of the time to convert it. And you can just define sane rules for them in the Git attributes file if they become a problem. But if they aren't a problem, you shouldn't generally care about this. So it's completely doable to mix operating systems, but it can cause friction, and it's good if you're aware of the friction points in advance. Something about documentation. So you should have some clear plans and guidelines for certain things like your branching. Which branches do you have? How do you do your version numbering, and how do you do tagging? And you should have naming conventions for branches and tags. Just rules and conventions for commit messages as well. And plan that how do you handle releases, hot fixes, and if you have different environments, how do you do that? Having rules and consistency, it just makes your life more manageable and less chaotic, and things are just more under control. You just spend less time thinking and more time doing. And about version numbering, it is a good idea to, when you set up your version control, at the start already have some kind of idea about this. Come up with some kind of strategy for it. Like, it's easiest to go with the standard major minor fixed digits, like 1.2.6 for example. Yeah, the fourth digit could be there, but I found that certain platforms might not like it, and you should check the formatting of those digits, that it pleases all the platforms that you're targeting. I think iOS specifically had some annoying rules about it. I've got scripts that just check that if version numbers are something that one of the platforms wouldn't accept and rejects them then. That kind of 3-digit setup is widely supported on all major platforms. Unity had the more innovative versioning scheme, the year going for a long time, but then they just changed it back to something a bit more sane. And you should try and automate your version numbering, because incrementing it manually every time you make builds, it just leads to errors and again causes you to think. But a bit more about that a bit later. But you just will save yourself a lot of work by automating it somehow. So let's get down to that automation. So it's something that you should familiarize yourself with, as it can save you a lot of time, because you don't have to then think about and suddenly start working on some these boring, repetitive chores that are part of your development. For example, GitHub, you can use GitHub Actions to run workflows. Unity has their own built automation that works seamlessly with the version control system. But yeah, those things cost money. But there are other solutions available as well. For all different kinds of version control, there are so many options, and you can even make a completely local setup, just running on like one computer in the corner of your office, if running virtual machines or containers in the cloud is just out of your scope. So that's not an excuse. So first thing to automate, I'd say, would be builds. They save you from locking up your game engine whilst you wait for the build to finish. They also limit the potential for human error in the build process. And so, for example, you can make an automation where it builds your project and uploads it somewhere every time you merge domain. And it can even create that nice tag for it. And that's it, you don't need to. That saves so much hassle from you. And for build deliveries, you can even automate delivering the build. I just said about uploading it somewhere, but you can also deliver it to different stores like to Steam, Google Play Store, iOS App Store, and it can fill all the information and version numbers and stuff for it automatically. Yeah, there might be some manual labor there, but that's something that actually needs some thought, like marketing related things and that kind of stuff to do with the releases. But you can automate the deliveries, a big chunk of it. And you can even hook different branches in your version control to different environments, like staging could deliver it to this private testing branch on Steam, and then your team can play the game on Steam and test it and see if it works. Or it can be even like a public beta branch on Steam as well. And then eventually when you find that, yeah, this works, the main branch merged there, and then it delivers it to the end users. And I mentioned about version numbers before. Those can be automated even in like a bit of a simple and stupid way. I found this fairly useful, that you can make tags in your version control system. You see those v1.0, for example, or v1.1, and make that kind of tags, and that decides the first 2 digits of your version number. So that tag becomes like 1.0 then. And then the third digit, it equals commits since the latest version tag. So as you can see there, each commit after that tag, it has a different third digit. And that's it. Now every commit in your repository has a unique version number. And yeah, I'm aware of this edge case that some of you might think of, that what if there are 2 different branches, there are 2 commits that are equally far away from that tag. Do they not have the same version number? Well, no, you can make it count it a bit differently so that it considers all the commits even in different branches, like commits since the tag. It gets slightly more complicated, but it is doable and it works. I can even, some people are interested, you can reach out and I can even give some advice how to do this. And you can find people have build different systems similar to this online as well. And tests can be automated. Yeah, test-driven development, that's always the dream, that you write the tests first, and if your code passes them, then it works. And if you change something and then the tests fail, instead of you running into, or your users running into bugs later. But it can be tricky in game development because it's so real time. There are some solutions to that, but it's still tricky. But at least having some tests, some sanity checks that, for example, would go through some of your mesh colliders in the project and checking that they are valid, for example, when you make a build, that's better than nothing. And you can make your automation run those tests before you build. And it can even do that every time you make a pull request, that if the pull request fails those tests, you immediately know to, even before anyone looks at it, you know that, oh, broke something, need to fix. And if the tests fail, the build won't go through, and you could even receive a message about it on Discord or Slack. And same for builds. Slack or Discord can announce that, oh, there's now a new build up, and people just find it. Producers usually love this feature. They don't have to be aware. They can just be on Discord or Slack and get all these nice builds delivered to them. Change logs can also be automated. Then you need to just take your commit messages even further and use this way of conventional commits. So you add these labels such as feed or fix and such to your commit messages. It is okay and it can work. This automatic system then takes those tags and generates automatic changelog when you merge, usually, that these things changed, and it just can recognize that which features were added and what was fixed and so on. But there are some shortcomings to it when used in practice. Not going there in much detail now, but generally if you use this workflow called rebase workflow in Git, they can be more correct and useful, but I'm not going there right now. Some of you might be aware of it, what I mean by rebase workflow, but it's not an initial concern to you right now, I wouldn't say. But definitely, if you're curious, look into it and maybe even try it and learn it. But I found that if you are a team of multiple different disciplines, it can alienate some less technical people. So I would call it the rebase workflow an advanced workflow. Yeah, and then of course you can have multiple repositories. It can be handy, but don't go mental about it because you should only do it when you actually need them. You can have repositories within repositories essentially. You can have your game and some modules there as separate repositories that have been linked. But that causes some friction as well to get them working together. It can be, there are some good pieces of software for that. The native Get submodules I dislike. They have the same effect that they can alienate some less technical people. And a lot of the time, utilizing a package manager can be a lot easier solution. So you can even have your private company repository where you have different kind of modules, and then in your repository you just define which packages to include. You can use manager, and that supports GitHub directly, for example, so you can have some packages in your repositories, and that works probably well enough for most people. And you can set up something more swanky if you actually need it. And then there are discipline repositories, like you would have the front end of your game, you know, where the end user actually plays the game, and then the back end, you know, the one that's running on the server side. You can have those just as separate repositories, but they're still part of the same project. Just a few examples. But yeah, think I'm near the end now. As a summary, you should pick the version control system that works for your team and you can afford. And Git is not the only option, even though everybody uses Git. And you should maintain your ignore file. Be aware of your binary files, how you managing them efficiently, and take operating system differences into account. And just have a clear workflow for branching, tagging, and deliveries. Minimize your thinking, and if some kind of general workflow that a lot of people use doesn't work for your team, don't be afraid to change it to suit your team better. If it's not restricted, if it's not banned by law, then try it if it works for you. And have your code reviewed before merging. That minimizes your mistakes. And you should use automation. For example, version numbering or builds. You try and minimize your manual labor. Then you get to focus on the game more. You can add more repositories, but only when you actually need them. Because they always add a little bit of burden. And I'd say that this is fairly good default for most projects. This kind of setup, that having main, having dev, and task branches. And that is a solid template for most projects. And if it's not, then you know what you're doing and you have something that works for you. But try and always challenge, does this work for us? Would there be a better way? Yeah, not that much time for questions, but yeah, I'm done finally.